Welcome to This Explainer. Today we're diving into a fascinating new research paper from the University of Chicago that reveals the hidden reason why your interactions with AI sometimes feel incredibly generic or just slightly off target. We're tackling the myth of the average AI and exploring exactly why a one-size-fits-all approach to aligning these models is fundamentally failing us. You know that feeling, right? You ask an AI for a quick breakdown and boom, it hands you a dense textbook chapter. Or on the flip side, you want a deep technical analysis, and you get this watered-down summary that sounds like a corporate PR statement. It's frustrating. But it turns out this isn't just a glitch in the prompt you wrote. It's actually a structural flaw baked into how these models are trained in the first place. So let's get right into it. Section 1, the average user myth. To understand what's going wrong here, we have to look under the hood at how AI actually learns what we want. The dominant method right now is something called reinforcement learning from human feedback, or RLHF. Basically, humans rate different AI responses, and the model learns to output what we generally prefer. But here is the massive catch. RLHF mathematically averages out our totally diverse, often contradictory human preferences into one single generic target. All of our totally normal disagreements are just treated as background noise, rather than meaningful signals of our distinct needs. The researchers frame this problem with a brilliant analogy. They note that this aggregated alignment is, quote, like designing a single shoe size for all humans. It fits no one well while claiming to serve everyone. They actually call this phenomenon preference mediocrity. We are quite literally forcing decisions using a reward signal that is suboptimal for pretty much everybody. Which brings us to Section 2, the cost of aggregation. Because this math problem has real-world fallout. Think about real human preferences as clusters. You've got some folks who want highly technical, formal answers, and others who need things super casual and accessible. But when you average those out, the resulting model lands perfectly in the middle of nowhere. It is a compromise that literally represents zero real users. By trying to split the difference between a formal expert and a casual novice, the AI ends up in this weird, empty space that doesn't even exist in the real world. Let's make this concrete. Imagine a software engineer trying to debug production code. They need dense, precise terminology and absolute zero fluff. Now, imagine a student learning to code for the very first time. They need an intuitive, easy-to-grasp analogy. A single, averaged-out response fundamentally fails both of them. It's going to be way too condescending for the engineer and entirely too complex for the student. These aren't just debates about the quality of a response. They are entirely legitimate differences in what is helpful based on the context. And, this goes way deeper than just whether an AI sounds polite or casual. This aggregation actually leads to the erasure of diversity. When preferences are aggregated through majority voting, minority viewpoints are fundamentally suppressed. The source data points out that current training datasets predominantly represent English-speaking, Western, educated populations. As a result, the AI's default behavior simply bakes in those dominant cultural norms while systematically marginalizing diverse global perspectives, particularly those from the global South. Plus, crucial situational context, like whether you're in a massive rush or just casually exploring a topic, is washed out entirely. So, how do we fix this? Section 3. The case for personalization. Once you spot this invisible flaw in how AI is trained, the solution starts to become clear. It all starts by acknowledging a really simple truth. Different users have entirely valid, distinct communication needs. Someone preferring a formal style and someone else wanting a casual chat, those aren't conflicting data points that we need to average out. They are distinct preference structures that should actually be preserved. And making that happen requires a huge structural shift. Instead of that single compromised model where everyone's individual quirks are lost, the proposed solution is a personal and adaptive model. In this setup, your individual variations are kept intact through user-specific models that actually adapt to your exact context, your level of expertise, and your cultural background. Okay, but the million-dollar question, does this actually work better? Absolutely. The empirical data cited in the paper shows that personalized models outperform standard, non-personalized ones by 15 to 30% across a huge variety of tasks. That is a massive jump in utility. And the best part? It's a Pareto improvement. That means users in the minority get substantially better service without degrading the experience for the majority. Now, of course, this brings up some valid concerns. Section 4, managing the AI risks. Look, if an AI knows exactly how to talk to you, what you value, and what your vulnerabilities are, it's entirely natural to worry about things like filter bubbles and manipulation. But the paper systematically breaks down these major counter-arguments. First up, scalability. Critics argue that running a personal model for 1 billion users is just way too expensive. But the reality is, new parameter-efficient methods, like LoRa, make this highly doable by modifying only a tiny, lightweight fraction of the model for each user. Then there's the fear of manipulation. The authors make a really compelling point here. Yes, personalized manipulation is a risk, but forcing everyone into an aggregated model is also a form of manipulation. It's just manipulation through homogenization. And finally, there's the worry that we'll lose shared standards of truth if everyone has their own AI, which leads us perfectly into their proposed solution. Section 5. Bounded personalization. To keep personalized AI safe, accountable, and tethered to reality, the authors introduce a definitive framework. They set up clear, normative rules for what an AI should and should not adapt to. If a behavior mostly has internal effects like tone, verbosity, or how much expertise it assumes, then yeah, it is entirely appropriate to personalize. The AI should respect your autonomy. However, behaviors with external effects like factual accuracy, safety-critical information, and preventing harm to third parties must remain strictly universal, regardless of what your stated preferences are. So, you can absolutely ask the AI to explain a complex scientific concept in the style of a pirate, but you cannot have the AI alter the actual scientific facts to suit your worldview. As these models scale up to become the fundamental infrastructure for global information access, we really have to rethink the foundation of how they are built. The myth of the average user has outlived its usefulness. So, to wrap up this explainer today, I want to leave you with this provocative question raised by the source material. As AI scales globally, aligned for whom? Next time you use a language model and it hands you a perfectly bland, middle-of-the-road answer, ask yourself, whose preferences is this system really serving?